Hello again, this is lesson 2.5, more reflection from spherical mirrors. You remember in our last demonstration we saw that anytime you put in rays of light at a spherical mirror and they're traveling parallel to the axis, they will reflect out through a common point right here called the focus. This is the point that's halfway between the actual surface of the mirror and the center of the mirror. There's another property that the focus has, which is going to help us when we start drawing rays. And it works like this. What happens if you have a ray of light and it comes in through the focus? Well, it comes in through the focus, it strikes the mirror. Right here, we have to determine what our normal line is going to look like. We want it to cross the mirror's surface at precisely 90 degrees. That looks pretty good. And now the reflected ray is going to go out on the other side of the normal line at exactly the same angle. That's our law of reflection, that theta reflected is always the same as theta incident. So, ray comes in, strikes, reflects out, seems to be headed pretty flat. Let's try a different angle and see what happens. Here's a ray coming in through the focus, hits the mirror again. Right at this spot, we have to figure out what our normal line looks like, and it's important to get these as accurate as you can, so take a minute, make sure you've got something that looks nice and square. The mirror's surface and your normal line should make a shape like a plus. It should look like there are 4 square corners here. If you don't have that, erase and try again. Once you have that, your reflected ray is going to go out on the other side of the normal line at the same angle. Those kind of went out the same way. Let's try a more extreme one and see what happens. We'll come in really sharp like this. Green ray coming down like so. Where's our normal line now? That actually looks pretty good right there. So now, when we draw a reflected ray, remember, we want to draw something that'll have the same angle below the normal as our original ray had above the normal. Looks about like that. Well, all of these rays are coming out horizontal, every one of them. No matter what I did to the angle, no matter what I did to the direction, a spherical mirror throws out rays parallel when you do this. This is another basic property of spherical mirrors. We saw in the last lesson that if a ray comes in parallel to the axis, it will bounce out through the focus. The converse is also true. If a ray comes in through the focus, it will go out parallel to the axis. In short, in through the focus, out parallel. Keep that in mind. That's going to be very important in 2.6.